Well, hello. Thanks for coming back for day two. So, when we met last time, we did discuss what a generator was, and we're going to reiterate that right now. So, a generator is um, an operation and a value that we use to get more numbers in a sequence. So, if I told you the generator was multiply, M-U-L, multiply by, I'll say 6. Multiply by 6. And let's say that I also say the first number in the sequence is the number 3. So remember, a sequence is just an ordered list. The first number is 3, and the generator is multiply by 6. Well, the next value then would be 3 times 6, 3 times 6, which is the number 18. So I would write an 18 for the second term in that sequence. Again, the generator here I'm telling you is multiply by 6. So I'm going to go from 3 to 18. If I multiply by 6 again, the next number in this sequence is 108. And if I multiply by 6 again, the next number is 648. So this keeps going on and on like that. So that's a sequence of numbers that started at 3 and had a generator of multiply by 6. Let's say that the number was, let's say the number was 1 over 12. Let's say that I have the same generator, but this time instead of starting with 3, I'm going to start with 1/12. Well, if I take 1 divided by 12, 1/12 the fraction, and I multiply that by 6, I'm going to get the number 1/2. And if I take the 1/2 and I multiply it by 6, it's going to give me the number 3. And if I take that and multiply it by 6, I'm going to get 18. So I can see that what the sequence is depends on two things. It depends on the initial value, right? Where does it start? Where does it start? And it also depends on the generator. Let's look at one more example. This time, instead of saying that my generator, right, here's a generator multiplied by 6. Let's say that my generator is add -2. Add -2. Well, I can have a sequence that also starts at 3, just like the one above, right? It starts at 3. But if my generator is add -2, the next term in that sequence is going to go to 1. Right? That's 3 plus -2. To get the next term in the sequence, I'm going to take the 1 and I'm going to add -2. 1 plus -2 is going to give me a -1. And if I add -2 again, I'm going to get -3. And when I add -2 again, I get -5. So here's a generator. This generator is add the number -2, and we can see the sequence that we get with that. And again, a sequence depends on, not only what the generator is, but also where it starts. So we need to know kind of what the beginning is, and what the generator is. So we were looking at sequences yesterday, and we're going to look at some on the next slide that you need to organize. But here is a sequence. Here's a sequence. It starts with 5/3, and it goes to 5, and then 15, and then 45, and then 135. The way that those numbers are getting, the distance between them is getting larger each time, I'm going to assume that it's not adding the same thing each time. I think this is a geometric sequence. It's one that involves multiplication. And if you want to know what the generator is, you can take a term in the list, like for example the 135, and you can divide it by the value that came before it. And it doesn't matter which one. I could take for example the 45 and divide it by the term that came before it. Right? I can take the 15 and divide it by the term that came before it, which is 5. Well, this one I know, right? 15 divided by 5 is 3. And if I do the other ones, 45 divided by 15, just as I suspected, and 135 divided by 45, magical. So it looks like the generator for this sequence, right, this sequence, its generator is multiply multiply by the number 3. So the generator is multiply by 3. And I could put in my calculator 5/3, right? 5 divided by 3, and then go times 3. And I can see it hits 5, and then 15, and then 45, and then 135. And if I was asked, hey, what's the next two terms in the sequence? Well, the next term after 135 would be 405, and then the term after that would be 1215. So that sequence involves multiplying by 3 each time. Let's look at one more example, and then we're going to move on here. On this one, I can see that the difference between the numbers doesn't seem like the differences aren't growing, right? They look, to my eye anyway, they look like they're about the same. So I'm going to work with the assumption that this is an arithmetic sequence. Arithmetic sequences grow using addition. And if I want to figure out what the common difference is, I would take any term in the sequence. For example, I'll take -2, and I would subtract the term that came before it. So you can see I'm taking this term and I'm subtracting the term that came before it. And -2 minus -4 is the same thing as -2 plus 4, which is +2. And I'll do it one more time. If I was to take the -4 and subtract -6, notice -4 minus -6. I was starting with -4 minus -6. That's -4 plus 6, which looks like +2. So it appears that the generator of this sequence, the generator is adding, or just add the number +2. I'm adding +2. And I can see, yeah, if I take -8 in my calculator and hit +2, yes, it hits -6, then -4, then -2, and then 0. And the next few terms would go to 2, right? 0 plus 2, and then it would go to 4, and then, 4 plus 2 would be 6, and 6 plus 2 would be 8, and 8 plus 2 would be 10. So that's the sequence. So on the next slide that you go to in Desmos, I would like for you to consider generators that involve multiplication or addition. And there's going to be several of them, and I'd like you to match each sequence with its generator.